Hello students, this is Dr. Prema Ma'am here, MC Department, New Horizon College. And in previous sessions, we have seen about several linear data structures, right? From arrays, stack, queues, linked lists. So many linear data structures we have seen. In this session, we will see few sorting techniques. Okay, so see, nowadays data searching is the biggest challenge task, right? So we have to search the data as fast as possible. So to searching the data, to find the data quickly, so some data ordering we should do, right? So for searching any element, the sorting techniques will be very helpful. Okay. So we have book index and all, right? Instead of searching without any idea, if it is ordered, so it will be very easy to search for any key or any items, right? So in our syllabus, we will discuss few sorting algorithms. Okay, nearly 7-8 sorting algorithms are there. Bubble sort, namely insertion sort, selection sort, radix sort, quick sort, merge sort, shell sort. Okay, so these are the some examples of sorting algorithms. Today in this session, we will see a very simple sorting algorithm, that is bubble sort, right? So what is the technique we are using in bubble sort? Okay, anyway, sorting, it can be in ascending order or it can be descending order, right? So we will consider only just we are sorting elements in ascending order. So how we can make it? That is, in bubble sort, how we are making it? We are just comparing two adjacent elements at a particular time, right? I'm just checking first and second element. I'm just checking whether it is perfect or not. If it is ascending order, I should check whether A less than B or not. If it is, I'm making descending order, I should check whether A greater than B. Correct. As now we just talk about only in ascending order. For example, I'm having 10, 8. Okay. So I have to check two adjacent elements. So I'm just checking 10 and 8. Whether 10 less than 8 or not. So first element should be lesser, right? In ascending order, it should be 8, 10, right? So 10 and 8 I'm checking. Those two adjacent elements I'm checking. Whether it is perfect, I'm not disturbing anything. But if it is not perfect, what I'm doing? I'm placing those two elements in a correct position, right? So this is the technique. Very simple sorting algorithm. What we are doing? Just taking two adjacent elements and comparing at a time. If it is perfect, we are leaving as such. If not, we are swapping or placing them in a correct position, right? And one more important point. So, how many number of passes we need to complete this sorting algorithm? So, each and every algorithm needs different counts of comparison or different counts of passes. That is based on our algorithm. It is not mandatory that all algorithms should follow in same way or same flow. It depends on algorithm, right? So in our bubble sort, it should have n minus 1 passes to sort. That is, n minus 1 times I should repeat the same checking or comparison, right? So how totally how many passes I need To complete this bubble sort, I should need n minus 1 comparisons. Just we will see with an example. Consider an array with 5 elements, right? So how we are making with passes? 5, 4, 3, 1, 2. So I have to make this in an ascending order. So obviously what is the result? 1, 2, 3, 4, 5. Right? I have to make this in ascending order. Just we have discussed to sort these elements, how many steps I should need totally, and minus 1 passes I need. So totally 5 elements are there. So how many passes I need, how many times I execute the same procedure, and minus 1 times nothing but 4 times I should execute the procedures. That is nothing but we'll call it as the passes. So 4 passes I need to sort the elements, right? So first pass we will see. Before that, just we have discussed what is the procedure, what is that bubble sort algorithm. What is the bubble sort algorithm? Nothing but comparing two adjacent elements. Okay, bubble sort is nothing but comparing two adjacent elements and arrange them in a perfect order. It can be ascending or it can be descending. So what is the given array? 5, 4, 3, 1, 2. So totally how many elements we have? 5 elements we have, right? So what is our motto here? We have to compare two adjacent elements. This is pass 1. At the first pass, what I'm doing, at the first loop, first pass, what I'm doing, I'm just comparing two adjacent elements. Whether it is perfect or not, no. It is not perfect in ascending order. So what I have to do, I have to swap 4 and 5. Right. So 5 and 4 here, I'm just checking whether it is proper ascending order or not. No, it is not proper. So I'm just swapping both the elements. So how it will become? 4, 5. Right. So 5, 4 I'm checking. It is not in order. So I swapped those 4 and 5. Next, what is the next step? Again, I have to compare next two adjacent elements. Again, I have to compare next two adjacent elements. So how I can compare? I'm just comparing 5 and 3. I'm just checking whether it is perfect or not. Whether it is perfect or not? No, it is not perfect. That is, it is not in ascending order. So again, I'm just swapping it, both 3 and 5. So I'm getting the 4 and 5, 3 got swapped. So 3, 5. Again, I am comparing these two adjacent elements. What and all I'm just checking? 5 and 1. Yes, again some problem. Again it is not in perfect order. I comparing. So what I got finally? 1 and 5. So again, last step at the end of pass 1, we have to compare 5 and 2. What will happen? I'm checking 5 and 2. Obviously, I need swapping because it is not in perfect order. So I'm just swapping. This is the end. So this is the given array. This is the given array. So at the first pass, okay, in bubble sort, just now we have seen totally we need n minus 1 passes. At the first pass, we are starting checking at two adjacent elements. First these two and these two and these two and these two, right? That is what we have done till this. And finally what we got, this is the final, at the end of first pass, this is the final array. So here we can conclude at the end of the first pass, the largest element in this array. Which is the largest element in this array? 5. So at the end of pass 1, the largest element in the array will find its place, will find its own place, right? So what is the thing we can conclude here? At the end of first pass, the largest element in the array will sit in its correct position, right? Next, this is our resultant array. So 5 is at the correct position. That is the largest element at the correct position. Next, we will start with second pass. What is the second pass? With the given resultant array, with the swapped array, we are just doing the next pass. But same procedure. What I have to do, I have to check 4 and 3, whether it is in perfect order or not. No, it is not in perfect. That is 4 greater than 3. No, I have to do the swapping. So after swapping, what I'm getting? 3 and 4. Again, 4 and 1 I'm checking. It is not in perfect order. So I'm swapping. Same procedure. In all the passes, we are doing the same procedure. Again, I'm swapping. I'm sorry, again I'm checking 4 and 2, whether it is perfect order or not. No, it is not in perfect ascending order. So I'm checking what? 4 and 2. These two also not in perfect order. So I'm just swapping both the values. Fine. And this place, I don't want to cross check with 4 and 5 because we are very sure about 5 already sorted. So no need to again cross check these two, right? So I'm just stopping one step before itself. I'm just stopping because last element found its place, found its correct position, right? So I don't want to cross check it again. So at the end of second pass, second largest element came to its correct position. See, at the end of second pass, second largest element came to its correct position. So what is second largest element? 4. So at the end of pass 2, number 4 have reached a correct position, right? So we will see third. At the end of pass 3, what will happen? The next largest element, that is 3, will come here, then 2 will go here, right? And so on. We will see what will happen in pass 3. This is the resultant array in pass 2. So as usual, same procedure. I am checking these two elements. It is not perfect, so I am just swapping. Again, these two elements I am checking. It is not perfect. I am swapping. And as I told, I don't want to check again with these two, right? Because both elements already found its place. So no need to again cross check with these elements. This is already sorted, right? So I'm stopping here itself. So at the end of the pause, my third largest element is also found its correct place, right? And you know, last pass. So from pass 3, what is the result we got? Because see, one more point here we have to remember, though the array is sorted, because our system doesn't know that. Anyway, it will work, it will run on the loop, whatever the program we have given. Though it is sorted or not sorted, it doesn't know. See, at the pass 4, yes, we know that it is already sorted, but my system doesn't know. Till the end of the loop, definitely it will execute, right? Okay. So again, I'm checking with the first two elements, adjacent elements. No need to change anything. It is perfect. So the resultant array is 1, 2, 3, 4, 5. So at the end of pass 4, we got the perfect ascending order elements, right? So that's all about bubbles. So very, very simple algorithm. What is the key point here? We have to compare two adjacent elements and have to arrange in an ascending order. From the beginning, from the first element, I'm cross-checking with second, and second and third and fourth, right? So in the same way, I have to do n minus 1 passes. N is nothing but total number of elements, right? So if there is 5 elements, I definitely have to do n minus 1 passes. And inside, I can do comparison also, right? Here both these two values I'm compare, and again these two I'm comparing, right? So comparisons also we have to do. And we'll see some key points about bubble sort. So just now we have seen how many passes I need, n minus 1 pass to sort an array, right? Totally n minus 1 passes, right? And also in each and every pass, two adjacent elements, right? What are the two adjacent elements? A of I and A of I plus 1, we are comparing. If it is in proper order, no need to change. But if it is not in proper order, what we have to do? We have to do the swapping, necessary swapping. We have to place in correct position. This is second important point. And one more important point, how many comparisons we need? How many comparisons? So just now we have seen, see, n minus k comparisons, right? N is nothing but number of elements, total number of elements. K is nothing but pass, whether it pass number. That is, just now we have seen at the first pass how many comparison we have done. Totally 5 elements are there, correct? At the first pass. So, for example, n is 5. First pass, so k is 1. So, at the first pass, how many comparisons we have done? 4 comparisons we have done. And in the second pass, how many comparisons we have done? Anyway, number of elements will be 5. At the second pass, how many comparisons we have done? 3 comparisons we have done, and so on. So in each pass, we definitely do these much comparisons, that is n minus k comparisons. So simplifying, first pass requires n minus 1 comparison, and obviously kth pass what we can write, n minus k comparison, because n is constant. And always last pass requires only one comparison, right? Okay. So from this, what we can, so from these findings, we can conclude the order of bubble sort, right? How we can conclude the order of bubble sort, we will see. Before that, we will see the sort algorithm. So bubble sort, A is nothing but array, N is number of elements. Okay. So just now we have seen pass, number of passes we have to mention. I'm starting with 1, the first pass, till the n minus 1, because n minus 1 passes we have to do. Again, each and every pass inside, how many comparison I have to do? Just now we have seen, since I'm starting with 0, so how many comparisons? N minus k minus 1. Since I'm starting with 0, that we should be very careful, right? Because this is for comparison. So what we have to do next step is, we have to compare the adjacent elements, right? If it is perfect, we are not doing anything. If it is not perfect, we have to swap both two elements.